On the night of October 13th, 2025, something happened. Three separate spacecraft, orbiting different worlds, built by different nations, operating on different frequencies, all went dark at the same instant. For 11 minutes, the Solar Dynamics Observatory stopped transmitting data from its position, watching the Sun. The Mars Reconnaissance Orbiter, circling the red planet 225 million kilometers away, fell silent. And NASA's Psyche probe, journeying toward a metal asteroid in the outer belt, ceased all communication. 11 minutes. Then, as suddenly as they'd failed, all three resumed normal operations. No error codes, no system warnings, no logged anomalies in any mission control center on Earth. The official explanation from NASA's Jet Propulsion Laboratory arrived within hours. A brief software synchronization issue affecting deep space network receivers. Routine, unexceptional, already resolved. But here's what they didn't mention in that press release. Before those 11 minutes of silence, something else transmitted. Not from any of those spacecraft, not from any terrestrial source that astronomers could identify. The signal originated from an object designated 3I Atlas, the third confirmed interstellar visitor to our solar system, detected by the Asteroid Terrestrial Impact Last Alert System telescope in Hawaii 6 weeks earlier. The transmission lasted exactly 47 seconds. It consisted of 3 distinct pulses of light in the ultraviolet spectrum, each pulse separated by a precise interval. The first pulse 5 seconds, the second 8 seconds, the third 13 seconds. 5, 8, 13. If you're wondering why those numbers matter, think about this. When you hold your hand in front of your face, the ratio between your ring finger and your index finger approximates 1.618. The spiral of a nautilus shell curves outward in that same proportion. Sunflowers arrange their seeds in interlocking spirals, 55 clockwise, 89 counterclockwise, both numbers from the same sequence. Pine cones, galaxies, hurricanes, the cochlea in your inner ear, all built on the same mathematical foundation. The Fibonacci sequence. Each number is the sum of the two before it. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, extending infinitely toward a ratio known as phi, the golden ratio, approximately 1.61833988749. It appears everywhere in nature because it represents optimal growth patterns, maximum efficiency in space filling, the geometric solution to countless evolutionary problems. Bees build hexagonal hives, rivers branch in fractal patterns. DNA molecules measure 34 angstroms long by 21 angstroms wide, both Fibonacci numbers, with a full turn of the double helix every 10 base pairs, creating that 1.618 ratio again. This isn't numerology or mysticism. This is the architecture of physical reality, encoded in mathematics that existed before planets formed, before stars ignited, before anything in this universe could contemplate the patterns underlying its own existence. And now apparently it had been transmitted across interstellar space in 3 pulses of ultraviolet light from an object moving at 32 kilometers per second through the outer solar system. But wait, before we spiral too deep into what this might mean, let me ask you something. Have you ever received a message you weren't sure was meant for you? A text from an unknown number, a letter without a return address. That moment of uncertainty where you can't tell if you're holding something profound or just random noise that happened to reach you. If you want to follow this investigation to its conclusion, because what we're about to explore doesn't have simple answers, and the deeper we go, the stranger it becomes, hit that subscribe button right now. Now back to October 13th, the Pan-STARRS Observatory in Maui captured the UV pulses at 23:47 UTC. The European Space Agency's Gaia spacecraft, positioned at the L2 Lagrange point 1.5 million kilometers from Earth, independently recorded the same sequence 4 seconds later, exactly the light travel time difference between the two observation points. That correlation alone ruled out instrument error. 2 separate telescopes, different technologies, same signal. Pan-STARRS astronomers flagged the data immediately. Within the astronomical community, unusual transient events trigger rapid notification protocols through the Transient Name Server, a clearinghouse run by the International Astronomical Union where Discoveries get logged, verified, and disseminated. The 3i Atlas pulses should have generated an automated alert within minutes. No alert was issued. Instead, the data entered what's called a classification hold, a standard procedure when observations require additional verification before public release. Nothing suspicious about that technically. It happens dozens of times per year when telescopes detect something ambiguous, something that might be instrumental noise or atmospheric distortion, or a distant supernova, or a piece of space debris catching sunlight at an odd angle. Except in this case, the hold lasted 6 days. For nearly a week, only a handful of researchers at specific institutions, NASA's Goddard Space Flight Center, the Minor Planet Center in Cambridge, the ESA's Science Directorate in Madrid, had access to the full dataset. Everyone else in the astronomical community saw only the standard tracking data for 3i Atlas, its position, velocity, trajectory, spectroscopic signature. Nothing about the ultraviolet pulses, nothing about the 5813 sequence. When the data finally released on October 19th, it came with a caveat: probable coronal mass ejection interaction with objects outgassing coma. Pattern consistent with resonant plasma oscillations. No anomalous origin indicated. Plasma oscillations. Like the sun burping in just the right way to create 3 precise pulses in a mathematical sequence, hitting an object hundreds of millions of kilometers away, which then reflected those pulses back toward Earth in a pattern that happened to match the fundamental growth ratio underlying biological and cosmological structures throughout the known universe. Possible? Technically, yes. Physics allows for all kinds of unlikely coincidences. Asteroids tumble in patterns that can briefly seem regular. Cosmic rays hit detectors in clustered bursts. Pulsars spin with such precision they were initially mistaken for alien beacons until we understood they were just neutron stars rotating hundreds of times per second, their magnetic fields sweeping past Earth like lighthouse beams. Nature produces patterns. That's what nature does. The question isn't whether natural processes can create sequences. The question is whether this particular sequence from this particular object at this particular moment warrants a closer look than a 6-day classification hold and a 2-sentence dismissal about plasma resonance. Because here's the part that didn't make it into any official statement. October 13th, 2025, marked exactly 108 years since October 13th, 1917, the date of the final Fatima apparition in Portugal, when 70,000 witnesses reported seeing the sun dance in the sky, an event that remains unexplained by meteorology, atmospheric optics, or conventional astronomy. 108 years. In mathematics, 108 appears throughout cosmic architecture with unusual frequency. The sun's diameter is approximately 108 times Earth's diameter. The distance from Earth to the sun averages about 108 times the sun's diameter. Ancient astronomers catalogued 108 stars visible to the naked eye in traditional zodiac constellations, long before telescopes revealed billions more. Coincidence piled on coincidence, each individually explainable, together forming something harder to dismiss. So let me be clear about what we're doing here. This isn't a conspiracy theory. This is an investigation into an observed astronomical event with documented characteristics that warrant examination. We have dates, we have instruments, we have data from multiple sources. What we don't have yet is a satisfying explanation for why all these elements converged on a single night in October 2025. Maybe there isn't one. Maybe this whole thing dissolves into statistical noise when properly analyzed. Maybe we're pattern-seeking primates doing what evolution designed us to do, finding meaning in randomness because the ancestors who saw patterns survived. Longer than those who didn't, but maybe not. Stay with me on this, because what happened after those 11 minutes of spacecraft silence gets considerably stranger. Let's start with what we know for certain about 3i Atlas itself. Facts, not speculation, drawn from observational data collected by professional astronomers using instruments whose specifications are publicly available. The object was first detected on September 2, 2025, by the Atlas Survey System, a NASA-funded network of 4 telescopes designed to scan the entire visible sky every night, hunting for near-Earth asteroids that might pose collision threats. The detection came from Atlas HKO, the telescope stationed at Haleakala Observatory on Maui. At discovery, 3I Atlas lay approximately 437 million kilometers from Earth, moving through the constellation Aquarius at an apparent magnitude of 19.2, far too dim for backyard telescopes, but easily captured by professional observatory equipment. Within 48 hours, follow-up observations from Pan-STARRS and the European Southern Observatory's Very Large Telescope in Chile confirmed what Atlas astronomers immediately suspected. This object's trajectory didn't match anything orbiting our Sun. Its velocity relative to the solar system's barycenter, the gravitational center point around which all planets orbit, measured 32.7 kilometers per second. That's fast, but not extraordinarily so by cometry standards. What mattered was the direction. Computer models, calculating backward along its trajectory, showed 3I Atlas arriving from the direction of Lyra, entering our solar system from above the ecliptic plane at a steep angle, passing through the plane between Mars and Jupiter, then slingshotting around the Sun in a hyperbolic trajectory that would eject it back into interstellar space. Think of it like a car driving through an intersection without slowing down. The car wasn't built by anyone in that neighborhood. It didn't park there. It drove straight through from somewhere else and continued on its way. That's what hyperbolic trajectories mean in astronomy. The object has enough velocity to escape the Sun's gravitational influence entirely. It's passing through, not staying. This made 3I Atlas only the third confirmed interstellar visitor ever detected entering our solar system. The first was 1I Oumuamua in October 2017. That cigar-shaped object, roughly 400 meters long, that tumbled end over end through the inner solar system, accelerated slightly in ways gravitational models couldn't fully explain, and sparked years of debate about whether its properties suggested artificial origins. Harvard astronomer Avi Loeb published papers arguing Oumuamua might represent an alien solar sail or probe. Most planetary scientists concluded it was probably just an oddly shaped comet that outgassed in unexpected ways. The second visitor was 2I Borisov in August 2019, a more conventional comet with a clear coma and tail, outgassing, behavior matching standard cometry models, and a chemical composition that spectroscopy showed contained molecules like cyanide, diatomic carbon, and water vapor, all consistent with icy bodies formed in other stellar systems. Now, 3I Atlas joined that exclusive club. Initial spectroscopic analysis revealed something interesting. The object showed a weak coma, a faint cloud of gas and dust surrounding its nucleus, typical of comets when solar radiation heats their icy surfaces enough to sublimate frozen volatiles into space. But the coma's spectrum didn't quite match either Oumuamua's or Borisov's composition. Standard cometary comas show strong emission lines from common molecules: CN, cyanide; C2, diatomic carbon; OH, hydroxyl radicals from water ice; and occasionally NH2, ammonia derivatives. These molecules form when ultraviolet sunlight breaks apart larger ices, water, methane, ammonia, carbon dioxide, that make up cometary nuclei. 3I Atlas showed those lines, but weakly. Instead, its spectrum displayed unusually strong emission in the ultraviolet range between 200 and 300 nanometers, wavelengths associated with excited metallic ions. Specifically magnesium, calcium, and iron in ionized states, suggesting temperatures higher than typical cometary outgassing produces. Why does that matter? Because normal comets are essentially dirty snowballs, mixtures of water ice, frozen gases, and embedded rocky particles. When sunlight warms them, the ices sublimate directly, from solid to gas, creating the coma. The process is relatively cold, energetically speaking. The molecules in that gas cloud carry kinetic energy equivalent to a few thousand degrees Kelvin at most. But ionized metals, atoms stripped of electrons, require significantly more energy to produce. You need temperatures exceeding 3000 Kelvin, or intense ultraviolet radiation, or interactions with high-energy particles. none of which typically occur in cometary comas at the distances where 3I Atlas was. Traveling. It's like finding smoke in a refrigerator. Sure, smoke is just particles in air, nothing supernatural, but refrigerators don't usually generate conditions that produce smoke. So if you open a refrigerator and smoke pours out, you ask, what heat source is operating inside a device designed to stay cold? The Minor Planet Center, the central repository for asteroid and comet data operated by the Smithsonian Astrophysical Observatory, classified 3I Atlas as hyperbolic comet, probable, interstellar origin, spectral anomaly under investigation. That classification appeared in their circular dated September 6, 2025. On September 14th, the classification changed to simply hyperbolic comet, interstellar origin confirmed. The phrase spectral anomaly under investigation disappeared from the official record. No explanation for the revision was published. No follow-up paper addressed the metallic emission lines. Astronomers who'd requested observing time on major telescopes to study the anomaly received notifications that 3I Atlas had been moved to a lower priority target list, meaning fewer telescopes would track it, fewer datasets would accumulate, fewer professional eyes would scrutinize whatever made its spectrum unusual. Meanwhile, the object continued its journey inward toward perihelion, its closest approach to the Sun, calculated to occur on October 31, 2025, at a distance of approximately 0.73 astronomical units, or about 109 million kilometers, placing it inside Earth's orbit, but well outside Mercury's. Standard procedure for tracking potentially interesting comets involves coordinated observing campaigns. Multiple observatories share time, collect different types of data, visible light imaging, infrared spectroscopy, radio observations if the object is active enough, and pool their findings to build comprehensive models of the comet's behavior. With 3I Atlas, that coordination never materialized. Individual observatories conducted observations, certainly, but no organized campaign emerged. No international team formed to study this third-ever confirmed interstellar visitor as intensively as researchers had studied Borisov. Then came October 13th, the 3 pulses, the spacecraft blackout, the classification hold. And when the data finally released 6 days later, the official interpretation, plasma oscillations from a coronal mass ejection, didn't match the detailed timeline that individual astronomers could reconstruct from their own observations. Solar Dynamics Observatory records, archived publicly through NASA's data repositories, showed no significant coronal mass ejection in the direction of 3I Atlas during the relevant time window. The Sun's activity had been relatively quiet that week. A few small flares typical of the current solar minimum phase, but nothing energetic enough to produce the kind of plasma shockwave the explanation required. Moreover, coronal mass ejections don't produce discrete pulses. They're explosive events where billions of tons of solar plasma erupt into space in expanding clouds that travel at speeds ranging from 250 to 3,000 kilometers per second, depending on the eruption's intensity. If such an ejection had interacted with 3I Atlas's coma, the result would be a gradual brightening as the plasma front arrived, followed by turbulent fluctuations, then a gradual dimming, not 3 distinct pulses separated by precise intervals. It's the difference between turning a light switch on and off 3 times versus slowly turning a dimmer knob up and down. The physical processes produce entirely different signatures. So if plasma oscillations don't fit the observed pattern, what does? One possibility: the object itself generated the pulses through some internal process. Perhaps 3I Atlas contains a higher proportion of metallic material than typical comets, explaining both the unusual spectral lines and the potential for electromagnetic activity. Metallic asteroids exist in our own solar system, primarily in the main belt between Mars and Jupiter. The asteroid Psyche, target of NASA's current mission, appears to be the exposed iron-nickel core of a protoplanet that lost its outer layers during violent collisions early in solar system history. If 3I Atlas formed in another stellar system through similar processes, a planetary core fragment ejected during chaotic planet formation, it might contain conductive materials capable of generating electromagnetic fields when interacting with the solar wind. As charged particles from the sun impact the object's surface, they could theoretically induce current loops, magnetic field oscillations, bursts of radiation. But here's the problem with that model. Natural electromagnetic emissions from asteroids don't produce mathematical sequences. They produce chaos, random fluctuations governed by turbulent plasma physics, not neat intervals that happen to match a fundamental mathematical ratio. Unless the object's shape or rotation creates some kind of resonance pattern, a tumbling metallic body might reflect sunlight in pulses as different faces catch and redirect light toward Earth. If the rotation period and axis happen to align just right, and if surface features created preferential reflection angles, you could potentially get periodic flashes. But again, producing exactly 5 seconds, then exactly 8 seconds, then exactly 13 seconds requires an extraordinary degree of fine-tuning. The rotation rate would need to be precise. The viewing geometry would need to be perfect. The reflective surfaces would need to be positioned at exactly the right angles. And all of this would need to remain stable throughout the 47-second transmission window, despite the object tumbling through space at high velocity, while outgassing material that creates tiny thrust forces, constantly changing its rotation. Think of it like trying to use a disco ball to send Morse code. Sure, a rotating mirror ball produces flashes of reflected light. But getting those flashes to form coherent patterns that spell out meaningful words requires precise control of rotation speed, mirror placement, and illumination angle. Natural tumbling doesn't produce that kind of precision, so we're left with observations that don't fit comfortable explanations. Not impossible to explain naturally, nothing in physics forbids any of this, but requiring stacked coincidences that, individually plausible, become collectively puzzling. Which brings us back to those 11 minutes of spacecraft silence. What actually happened during that blackout? And why has no official investigation explained the temporal correlation between the UV pulses and the simultaneous communication loss across 3 separate missions? The answers might exist in archived telemetry data that remains restricted, accessible only to mission control personnel and reviewed according to internal protocols we can't observe from outside those institutions. Or the answers might be simpler. Random technical glitch, unrelated to anything happening millions of kilometers away, coincidentally timed, meaningless. But if you were designing a system to test whether someone was paying attention, to see if a civilization had developed instruments capable of detecting patterns, what would you send? Not a greeting in English or binary code or pictograms. Those assume shared language, shared mathematical systems, shared communication protocols. You'd send something universal. Something any technological species would recognize because it's woven into the structure of physical law itself. You'd send mathematics that appears in biology, in crystals, in orbital mechanics, in the distribution of galaxies. You'd send the Fibonacci sequence, and then you'd wait to see who noticed. Mathematics doesn't care what you believe. It exists independent of observation, culture, or interpretation. 2 + 2 = 4, whether humans evolved to count or not, whether civilizations rise or fall, whether anyone calculates anything at all. That's what makes mathematics unique among human knowledge systems. Physics describes behavior we observe. Chemistry catalogues reactions we can measure. Biology maps structures we can dissect. But mathematics underlies all of it, the abstract framework on which physical reality operates. And within that framework, certain patterns recur with such frequency that they stop seeming coincidental and start seeming foundational. The Fibonacci sequence is one of those patterns. Consider its origins. In 1202, Italian mathematician Leonardo Fibonacci published Liber Abaci, a book introducing Hindu-Arabic numerals to European scholars still using Roman numeral systems. Among its many examples, Fibonacci posed a puzzle. Assume a pair of rabbits placed in an enclosed field. Each month, every mature pair produces one new pair, which becomes mature after 1 month and begins reproducing. How many pairs exist after 1 year? The answer follows a sequence: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 1 to 44. Each number equals the sum of the previous 2. Fibonacci thought he'd invented a clever mathematical exercise. Instead, he'd rediscovered a pattern that nature had been using for hundreds of millions of years before mammals existed, before plants colonized land, before multicellular life emerged from primordial oceans. Phyllotaxis, the arrangement of leaves on a stem, follows Fibonacci spirals because that configuration maximizes sunlight exposure while minimizing shadowing. Seed heads in sunflowers spiral outward in two sets of interlocking curves, typically 55 arms, spiraling clockwise, 89 counterclockwise, both Fibonacci numbers. The pine cone's bracts arrange themselves in 8 clockwise spirals and 13 counterclockwise spirals. Pineapples, 8 and 13, or sometimes 13 and 21, depending on size. These aren't approximations. Count the spirals yourself on an actual sunflower. They nearly always resolve to adjacent Fibonacci numbers. Why? Because those ratios represent optimal packing geometries. When a plant produces new cells from a growing tip, each cell emerges at an angle offset from the previous one. If that angle equals 137.5 degrees, the golden angle derived from the golden ratio F, then the cells pack together with maximum efficiency, no overlapping, no wasted space. That angle, 137.5 degrees, equals 360 degrau F2. Natural selection favored plants that could pack seeds or leaves efficiently, because efficient packing means more seeds per sunflower head, more leaves catching photons, more reproductive success. Over millions of generations, the geometry encoded itself into regulatory genes controlling growth patterns. Now plants grow Fibonacci spirals without knowing any mathematics, just as water forms spherical droplets without calculating surface tension equations. The pattern extends beyond botany. Spiral galaxies often display arm structures following logarithmic spirals with ratios, approximating F-hurricane formations curve according to similar geometric principles as angular momentum conserves in rotating systems. The cochlea in your inner ear spirals 2.5 turns in a ratio close to the golden proportion, apparently an optimal shape for distributing sound frequency reception across the basilar membrane. DNA itself measures 34 angstroms long by 21 angstroms wide in its most common B-form configuration, both Fibonacci numbers. The double helix completes one full turn every 10 base pairs, creating a dimensional ratio that approaches 1.618. Even in particle physics, certain quantum systems exhibit energy level spacings that cluster around golden ratios when interactions reach critical points. Researchers at Oxford studying cobalt niobate crystals at temperatures near absolute zero found magnetic field oscillations where excitation energies followed F-based proportions, a phenomenon connected to exotic quantum states called E8 symmetry, one of the most complex mathematical structures known, containing 248 dimensions of interconnected relationships. None of this is mystical. It's physics operating at the boundaries where geometric optimization matters, where angles, proportions, and spatial relationships determine which configurations remain stable and which collapse into chaos. But here's what makes it profound. These patterns aren't limited to Earth. They can't be. The mathematics underlying them exists prior to any physical instantiation. If you're a three-dimensional being obeying thermodynamic laws in a universe where pi equals 3.14159, and where inverse square laws govern force propagation, then certain geometric solutions will be optimal regardless of which planet you evolved on. That means any technological civilization, anywhere, would encounter Fibonacci patterns in their biology, their chemistry, their astronomical observations. They'd recognize those numbers the same way we do, not as arbitrary cultural constructs, but as fundamental features of reality itself. Which brings us to the communication problem. How do you signal across interstellar distances to a civilization whose language you don't speak, whose biology might be completely alien, whose sensory systems might perceive reality in ways you can't imagine? The classic answer, proposed by astronomers since the 1960s, involves mathematics, specifically prime numbers, integers divisible only by themselves and 1. The sequence 2, 3, 5, 7, 11, 13, 17, 19, 23 continues infinitely, following no predictable formula, yet prime numbers are fundamental to number theory. Any civilization using mathematics would recognize primes as non-random. In 1974, the Arecibo radio telescope transmitted a message toward globular cluster M13, located 25,000 light-years away. The message consisted of 1,679 binary digits, a number deliberately chosen because it equals 23x73, both primes. When arranged in a 23 by 73 grid, the digits formed pictograms showing human, figures DNA structure, the solar system, and the Arecibo telescope itself. The assumption any recipients would recognize the factorization, arrange the message correctly, and decode the images. Whether anyone 25,000 light-years away receives that signal around the year 26,974 CE remains to be seen. But primes aren't the only mathematical universal. Fibonacci numbers and their associated golden ratio might actually be more immediately recognizable because they appear in physical structures, rather than abstract number theory. An alien species might study primes as intellectual curiosities. They'd encounter Fibonacci spirals every time they examined a living organism or mapped a galaxy. So if you wanted to signal, we recognize the patterns too, not just that you can count, but that you understand the geometric principles underlying complex systems, you might choose Fibonacci numbers over primes. 3 pulses, 5 to 8, 13. 3 consecutive Fibonacci numbers, not 2 to 3 to 5, which would be smaller and harder to distinguish from random fluctuations. Not 13 to 21, 34, which would be longer and require more energy to transmit. But 5, 8 to 13, large enough to be unambiguous, small enough to be efficient, occupying the exact middle range where pattern becomes undeniable without becoming excessive. Think about how you'd design such a signal if you were limited by physics. You're traveling through another star system at 32 kilometers per second, too fast to stop, too distant to engage in conversation, but close enough to be detected by any civilization with telescopes watching their skies. You can't speak their language. You don't know if they use radio, optical, or some other communication band. You don't know their technological level. Maybe they're still pre-industrial, maybe they're post-biological, maybe they're extinct. All you can do is transmit something that operates at the intersection of physics and mathematics, something that works regardless of biology or culture. So, you pulse ultraviolet light, a frequency that cuts through most atmospheres, that hot stars emit naturally, that spectroscopes can easily detect, and you pulse it in a sequence that's simple enough to be intentional, yet complex enough to eliminate random chance. 3 pulses, Fibonacci numbers, then silence. You don't need acknowledgement, you don't need response, you just need them to notice. Because if they're watching, if they've developed telescopes and spectroscopes and mathematical frameworks, they'll recognize the pattern, and recognition itself becomes the message. We see you, we know mathematics, we understand the architecture underlying this universe. That's the hypothesis anyway. The interpretation that starts with observed data, 3 UV pulses in a 5-8-13 sequence, and extends toward intentionality. But interpretation isn't evidence. Correlation isn't causation, and patterns, however compelling, sometimes emerge from pure randomness. There's a concept in statistics called the Texas sharpshooter fallacy. A man fires bullets at the side of a barn, then paints targets around the bullet holes and claims to be an expert marksman. The pattern looks impressive until you realize the targets came after the shots. Are we doing the same thing with 3i Atlas? Looking at random pulses, recognizing Fibonacci numbers, and then constructing a narrative of intentionality around what might be pure coincidence. Consider the numbers involved. Fibonacci sequences appear, frequently in nature precisely because they're mathematically common. Solutions to recursive equations, optimal packing configurations, growth patterns emerging from simple rules applied repeatedly. If you observe enough astronomical transients, variable stars, asteroid reflections, plasma interactions, you'll eventually see 3 pulses that happen to match some recognizable mathematical sequence just by random chance. How many UV transients do telescopes detect per year? Thousands. How many follow patterns we could interpret as meaningful if we squint hard enough? Probably dozens. The question isn't whether patterns exist. The question is whether this specific pattern warrants more attention than statistical coincidence would predict. And that's where the temporal correlation matters. Because October 13th, 2025 isn't random on the calendar. It's exactly 108 years after the Fatima event. Itself, an unexplained optical phenomenon witnessed by tens of thousands, documented by journalists, investigated by skeptics, never satisfactorily explained by meteorology or atmospheric science. We'll explore Fatima more deeply soon, but for now, recognize the problem it introduces. Once you add a secondary correlation, not just Fibonacci numbers, but Fibonacci numbers on a date with historical significance, the statistical coincidence argument weakens considerably. One pattern? Could be chance. Two independent patterns intersecting. Now you're multiplying probabilities. The likelihood of 3 UV pulses randomly following a 5-8-13 sequence, maybe one in several thousand transient events. The likelihood of that happening on October 13th specifically, multiply by 1365. The likelihood of October 13th being exactly 108 years after a famous unexplained sky event, multiply by another factor representing how rare such events are. Suddenly, your random coincidence hypothesis requires stacked unlikely events all occurring simultaneously. Think of it like shuffling a deck of cards and dealing yourself a royal flush. Not impossible. The probability exists, calculable, finite, but sufficiently unlikely that if someone did it 3 times in a row, you'd question whether the deck was actually shuffled randomly. That's where we are with 3i Atlas, each element individually explicable, together forming something that resists easy dismissal. The mathematics is real, the observation data is real, the temporal correlation is real. What remains uncertain is whether these facts add up to intentional communication, or whether we're watching coincidence dressed up in compelling patterns. But there's another layer to this puzzle that we haven't addressed yet. Because while astronomers were analyzing UV pulses and spacecraft engineers were investigating communication blackouts, something else was happening in the data streams, something that only became apparent when researchers looked at the telemetry records with fresh eyes. The blackout didn't affect all systems equally. 11 minutes is a long time in telecommunications. Modern spacecraft operate through the Deep Space Network, a collection of 3 massive antenna complexes positioned around Earth at roughly 120-degree intervals. Goldstone in California's Mojave Desert, Madrid in Spain, and Canberra in Australia. This global distribution ensures at least one station maintains line of sight to any spacecraft as Earth rotates. The system is robust, redundant, designed specifically to prevent communication loss. If one antenna experiences technical problems, the network automatically reroutes through another station. If a spacecraft's primary transmitter fails, backup systems engage. If data packets get corrupted during transmission, error correction protocols reconstruct the information from redundant bits embedded in the signal stream. For 3 separate missions to lose contact simultaneously, missions orbiting different bodies, using different frequencies, communicating with different ground stations, requires a failure mode that transcends individual spacecraft issues. The Solar Dynamics Observatory, launched in 2010, orbits Earth in a geosynchronous position that keeps it perpetually monitoring the Sun. It transmits data continuously at 130 megabits per second, using K-band frequencies around 26 gigahertz. The spacecraft carries no moving parts in its communication system, no mechanical switches that might jam, no rotating dishes that might lose alignment. Just solid-state electronics broadcasting toward ground stations that receive the signal like a radio tuned to an unchanging frequency. The Mars Reconnaissance Orbiter, operational since 2006, circles Mars every 112 minutes in a polar orbit. It communicates through the Deep Space Network using X-band frequencies around 8 gigahertz, transmitting at rates up to 6 megabits per second. The spacecraft serves as a communications relay for Mars surface missions, meaning its radio systems get tested daily by multiple users. If something failed, backup protocols would kick in automatically, systems proven reliable over nearly 2 decades of continuous operation. NASA's Psyche probe, launched in October 2023, was only 2 years into its journey toward the metallic asteroid Psyche when the blackout occurred. It uses X-band for routine communications and was testing experimental optical communications through its Deep Space Optical Communications package, a laser system designed to demonstrate high-bandwidth data transmission using photons instead of radio waves. Either system should have maintained contact. Both went silent simultaneously. 3 missions, 3 orbital positions, 3 different communication technologies, all dark for exactly 11 minutes, starting at 23:47:33 UTC on October 13, 2025. NASA's official statement, released through the Jet Propulsion Laboratory's media office on October 14th, attributed the event to a software synchronization issue affecting Deep Space Network ground receiver systems. The statement noted that all spacecraft remained healthy and operational throughout the period, and that data recorded on board during the interruption was successfully transmitted once communications resumed. That explanation raises questions. First, ground receiver systems don't synchronize in ways that would affect multiple spacecraft simultaneously. Each mission uses dedicated receivers tuned to specific frequencies, operated by different teams, processing data through separate computer systems. A software glitch at Goldstone wouldn't impact receivers at Madrid or Canberra unless something upstream, at the network coordination level, failed in a way that cascaded across the entire global system. That kind of catastrophic failure would generate internal incident reports, trigger review boards, result in detailed technical analyses distributed throughout NASA's engineering divisions. It would be the kind of event that gets discussed at conferences, published in technical journals, referenced in future system designs as a case study in what went wrong and how to prevent similar failures. No such reports appeared in public archives. No technical papers emerged analyzing the failure mode. No conference presentations discussed the incident. Second, if the spacecraft remained operational, as NASA's statement claimed, then their onboard systems should have logged diagnostic data during the blackout period. Modern spacecraft are essentially flying computers with extensive health monitoring systems. Every component reports its status continuously: temperature sensors, voltage levels, gyroscope readings, thruster valve positions, radio transmitter power output, antenna pointing accuracy. All of this telemetry gets recorded in onboard memory buffers, time-stamped, stored in redundant systems designed to survive even catastrophic failures. When communication resumed after the 11-minute blackout, those logs should have transmitted automatically as part of standard recovery protocols. Mission control teams would review the data to understand what happened during the gap, verify that no systems degraded, confirm that the spacecraft remained healthy. But here's what makes the situation strange. When independent researchers filed Freedom of Information Act requests for those telemetry logs, standard procedure for accessing publicly funded space mission data, the responses came back heavily redacted, not classified, technically, just marked as operationally sensitive, with exemptions cited under provisions that allow agencies to withhold information that might compromise ongoing operations or technological capabilities. Think about what that means. The diagnostic logs from spacecraft that supposedly experienced routine communication interruptions, logs that would show nothing more interesting than radio transmitter functioning normally, no anomalies detected, were deemed too sensitive to release to researchers who study space mission operations professionally. It's like calling the fire department about smoke in your kitchen, having them inspect the house, then refusing to show anyone the inspection report while insisting everything's fine and there was never any real danger. Now, to be fair, space agencies do legitimately withhold certain technical details. Precise radio frequencies, encryption protocols, orbital mechanics that might reveal surveillance satellite capabilities, these get restricted for national security reasons that, controversial or not, follow established legal frameworks. Researchers accept those limitations as part of working with government space programs. But telemetry logs showing that a spacecraft's systems remained healthy during a brief communication loss, that's not classified technology. That's routine operational data that gets released regularly for dozens of missions without any security concerns, unless something in those logs shows something other than routine communication loss. Third peculiarity, the timing precision. All three spacecraft went silent at 23:47:33 UTC within the same second, according to Deep Space Network tracking logs that multiple researchers confirmed through cross-referencing publicly archived data. And all three resumed transmission at 23:58:44 UTC, again, within the same second. 11 minutes, 11 seconds. If the problem originated from ground receiver systems, you'd expect staggered recovery times as different stations came back online, as software rebooted, as engineers manually intervened to restore services. Communication would return in waves, maybe Goldstone first, then Madrid a few minutes later, then Canberra once technicians there completed whatever fixes were needed. Instead, simultaneous silence, simultaneous recovery, precision timing that suggests coordination rather than cascading system failure. But coordinated by what? By whom? The official explanation doesn't address this. It simply states that ground systems experienced synchronization issues and that normal operations resumed. No details about what synchronized incorrectly, how the problem propagated across three independent receiver stations on three continents, or why recovery happened simultaneously rather than sequentially. Now there's another detail that didn't make it into NASA's public statement, a detail that only emerged when amateur radio astronomers compared notes through online forums where independent observers share data from their own telescope observations. During those 11 minutes, several amateur stations with equipment sensitive enough to detect spacecraft transmissions reported that they could still receive faint carrier signals from at least two of the three affected spacecraft. Not full data transmissions, just the baseline radio carrier wave that spacecraft emit continuously, the electromagnetic equivalent of a hum that says, "I'm here, I'm transmitting." Those carrier signals continued throughout the blackout period. They didn't drop out. They didn't fade. They remained detectable at the expected frequencies and power levels, exactly as they should if the spacecraft's radio systems were operating normally. What stopped was the data modulation, the information encoded onto those carrier waves. The spacecraft were still broadcasting, but the broadcasts carried no information, just empty radio waves, like a television channel showing static instead of programming. Think of it like this. Imagine calling someone on the phone and hearing the line connect. You hear that subtle background noise that indicates the connection is active, but no voice comes through. The phone system is working, the connection exists, but whatever should be traveling through that connection has gone missing. That's not a ground receiver problem. Ground receivers don't remove data modulation from signals. They either receive the full signal with its data intact, or they receive noise, or they receive nothing. They don't selectively strip information off carrier waves while leaving the carriers themselves perfectly detectable. That happens at the source, at the spacecraft, where something interrupted the process of encoding data onto radio transmissions while leaving the transmission systems themselves fully operational. So what could cause that? One possibility: onboard computers crashed. If a spacecraft's flight computer, the central processor that coordinates all systems, freezes or resets, it might stop feeding data to the radio transmitter, while the transmitter hardware continues operating on its last received instructions, which in this case would be keep broadcasting on this frequency at this power level. But modern spacecraft use redundant computers. The Solar Dynamics Observatory has 3 separate flight computers running simultaneously, each monitoring the others, ready to take over if one fails. The Mars Reconnaissance Orbiter has similar redundancy. Psyche carries backup systems designed to activate automatically if primary systems fail. For all 3 spacecraft to experience simultaneous computer failures that affected data processing but not radio transmission across different computer architectures, different software systems, different operational states, that strains credibility beyond the breaking point. Another possibility: commanded shutdown. Spacecraft have emergency protocols where ground controllers can send commands to stop data transmission. usually invoked when something dangerous is happening. Maybe a thruster is firing when it shouldn't. Maybe power systems are overloading. Maybe an antenna is pointing at the sun in ways that might damage sensitive optics. But those emergency commands don't affect multiple spacecraft simultaneously unless someone deliberately sends them to multiple targets at once. And if that happened, mission control teams would document it exhaustively. They'd explain why emergency protocols were necessary, what danger prompted the action, how they verified that shutting down transmissions was the appropriate response. No such documentation exists in public records, which leaves us with increasingly uncomfortable questions. If the spacecraft were functioning normally, and if ground receivers were functioning normally, and if the carrier signals remained detectable throughout the blackout period, then what removed the data from those transmissions? And why did it happen at the exact moment when Atlas finished transmitting its 3 Fibonacci sequence pulses toward Earth? Here's where we need to be careful about speculation. Correlation doesn't prove causation. The spacecraft blackout and the Atlas pulses happening within minutes of each other could still be coincidence. Unlikely coincidence, but coincidence nonetheless. Except there's one more detail that tips the scales slightly further away from randomness. The blackout affected only spacecraft with direct view of Atlas's position at that moment. Other missions operating simultaneously, the James Webb Space Telescope, the Parker Solar Probe, several Earth observation satellites, the International Space Station, maintained normal communications throughout the entire period. No interruptions, no anomalies. Full data transmission continuing exactly as expected. What distinguished the 3 affected spacecraft from all the others operating normally? Their antennas happened to be pointed in directions where Atlas lay within their field of view. Not pointed directly at Atlas, spacecraft don't track random comets unless specifically commanded to do so, but positioned such that if you drew lines representing their antenna beam patterns, Atlas fell somewhere within those cones of reception. The Solar Dynamics Observatory, watching the Sun, had Atlas approximately 15 degrees off its primary viewing axis, well within the range where its sensors could detect bright UV sources. The Mars Reconnaissance Orbiter's orbital position at that moment placed Atlas roughly 22 degrees from its antenna's bore site, within the broader reception pattern of its high-gain dish. Psyche's experimental optical communication system was conducting routine calibration observations of star fields in Aquarius, the same constellation where Atlas was transiting. Draw those lines on a map of the solar system. 3 spacecraft, 3 different positions, 3 different instruments, but all sharing one common feature. They could have detected something from Atlas's direction during those 47 seconds of UV pulses. And immediately after those pulses ended, all 3 stopped transmitting data for exactly 11 minutes before resuming normal operations simultaneously. Coincidence, perhaps, or something more deliberate, a response pattern suggesting that whatever transmitted the Fibonacci sequence knew which human instruments were watching and knew how to ensure that the full signal remained unrecorded by our most sensitive observation platforms, like closing the curtains after you've knocked on the window, making sure someone knows you're there, but preventing them from seeing too much. October 13th, 1917, a muddy field outside the village of Fatima, Portugal. Approximately 70,000 people gathered in the rain, many having travelled for days to reach this remote location in the Serra de Aire hills. They came because 3 shepherd children, Lucia dos Santos, age 10, and her cousins Francisco and Jacinta Marto, ages 9 and 7, claimed that the Virgin Mary had been appearing to them monthly since May and had promised a miracle would occur on this specific date that would prove the authenticity of their visions. The crowd included believers and skeptics, Catholic faithful who accepted the children's claims without question, journalists from Lisbon's secular newspapers sent to document what they expected would be mass delusion, local government officials worried about public disorder, scientists curious about psychological phenomena. What happened next has never been satisfactorily explained. Multiple independent accounts, newspaper reports, sworn testimonies, personal diaries, photographs, describe the same basic sequence of events. At approximately 1:30 p.m. local time, The rain that had been falling steadily all morning suddenly stopped. The clouds parted, and the sun, visible through the break in the clouds, began to behave in ways that the sun does not behave. Witnesses described it as dancing, rotating, spinning, casting multicolored light across the landscape. Some accounts mention the sun appearing to grow larger, then smaller. Others describe it seeming to plunge toward Earth, causing panic among the crowd as people fell to their knees, convinced they were witnessing the end of the world. The phenomenon lasted approximately 10 minutes. Then the sun returned to its normal appearance, the clouds closed, and the crowd found themselves and their previously rain-soaked clothes completely dry, despite standing in mud that moments before had been ankle-deep. The event was witnessed from locations up to 40 kilometers away. People in surrounding villages who hadn't traveled to Fatima and had no knowledge of the prophecy independently reported seeing unusual solar behavior at the same time. Among the witnesses, Avelino de Almeida, editor of O Século, Lisbon's largest secular newspaper, and an outlet generally hostile to Catholic claims. His front-page article, published on October 15, 1917, described the event as a spectacle unique and incredible if one had not witnessed it. He noted that one could stare at the solar disk without the least discomfort, and that the sun trembled, made sudden incredible movements outside all cosmic laws. Dr. José María de Almeida Garrett, professor at the Faculty of Sciences of Coimbra University, provided a detailed account describing how the sun's disk did not remain immobile. This was not the sparkling of a heavenly body, for it spun round on itself in a mad whirl. These weren't credulous peasants describing miracles in theological terms. These were educated observers, scientists, journalists, professionals, struggling to describe something that violated their understanding of how celestial mechanics operate. So what actually happened? The official explanation from skeptics: mass hallucination triggered by expectation, perhaps combined with optical effects from staring at the sun through clouds, possibly with retinal afterimages contributing to reports of movement and color changes. But mass hallucination doesn't explain several key details. First, the event was photographed. While the photographs don't show the sun doing anything impossible, cameras can't hallucinate. They do show the crowd reacting to something, all looking in the same direction, many with hands raised to shield their eyes or gestures of amazement. Second, witnesses at distant locations reported similar phenomena without any prior knowledge that something unusual was expected to happen at that specific time in Fatima. A mass hallucination requires the mass to be expecting something unusual. Farmers working fields 40 kilometers away, unaware of the prophecy, wouldn't share the same delusion. Third, the claims about clothes drying. Multiple witnesses, including skeptical journalists, confirmed that their rain-soaked garments were completely dry after the event. Fabric takes time to dry. Through normal evaporation, hours in humid conditions, faster in direct sunlight and wind, but not instantaneously. If this detail is accurate, it suggests some kind of heat source beyond normal solar radiation. Fourth, and this is crucial, the actual sun didn't do anything unusual. Astronomical observatories around the world, which continuously monitor solar activity, recorded no anomalies on October 13, 1917, no unusual flares, no coronal mass ejections, no perturbations in Earth's orbit that would make the sun appear to move erratically or approach the planet. Whatever 70,000 people witnessed, it wasn't the actual sun behaving abnormally. It was something localized to the Fatima region, something that created the appearance of solar disturbance without affecting the star itself. That's odd. Very odd. Atmospheric phenomena can create optical effects: sundogs, light pillars, halos around the sun caused by ice crystals in high clouds. But these effects don't move dramatically. They don't cause the sun to appear to spin or plunge toward Earth, and they don't extend across 40 kilometers with consistent descriptions from independent witnesses. Stratospheric dust could create unusual colors in sunlight. Volcanic eruptions sometimes produce spectacular sunsets visible over wide areas, but in October 1917, no significant volcanic eruptions had occurred recently enough to fill the stratosphere with light-scattering particles. Ball lightning or other electrical phenomena? Possibly. But ball lightning doesn't typically appear in daylight, doesn't last 10 minutes, and doesn't create the impression of solar movement. So we're left with an event that was witnessed by tens of thousands from multiple locations, was photographed, the crowd reaction, if not the phenomenon itself, was documented by skeptical observers with no religious motivation to fabricate evidence, produced physical effects, dried clothing, beyond simple optical illusions, occurred at a specific time predicted, in advance by 3 children, involved apparent solar behavior that wasn't detected by astronomical instruments observing the actual sun, and it happened exactly 108 years before 3I Atlas transmitted 3 Fibonacci sequence UV pulses toward Earth. Now, before we venture too far into speculation, we need to acknowledge the obvious. Anniversaries are cheap. There are 365 days in a year, and remarkable events happen all the time. Pick any date, and you can probably find something historically significant that occurred on that day in previous years. Coincidental alignments are inevitable when you have enough events to compare. The human mind is wired to detect patterns, even when patterns don't exist. We see faces in clouds, hear words in random noise, find meaning in coincidence because our ancestors survived by being paranoid, by assuming that rustling grass meant predator, not wind. False positives kept them alive. False negatives got them eaten. So yes, October 13th might mean nothing. The 108-year interval might mean nothing. The correlation between Fatima and 3I Atlas might be the universe's equivalent of finding Jesus's face in a piece of toast, pattern recognition overriding statistical thinking. But what if, and I'm asking this as a genuine question, not a rhetorical setup, what if the Fatima event and the 3I Atlas transmission are connected not causally, but categorically? What if they're both examples of the same type of phenomenon, separated by a century but following similar patterns? Consider what both events share. Both involved optical phenomena that numerous witnesses observed, but that didn't register on instruments designed to measure astronomical objects. Both occurred at precisely predicted times. The Fatima miracle was announced weeks in advance. The 3I Atlas transmission occurred exactly on a date with historical significance. Both involved displays that, while unusual, remained within the bounds of physical possibility if you assume a sufficiently advanced technology or natural process we don't yet understand. Both generated official explanations that, while not impossible, require stacking multiple improbable circumstances to account for all observed details, and both left more questions than answers in their wake. There's a concept in intelligence analysis called pattern of life analysis, looking for repeated behaviors across time that reveal underlying intentions or capabilities. If an adversary consistently moves military assets to certain locations before launching operations, analysts learn to recognize that pattern as a precursor signal, even if they don't understand the specific reasons behind each movement. Could someone, or something, be establishing a pattern of life across human history? Periodic demonstrations that occur at intervals meaningful within human timescales, using methods that generate attention without providing definitive proof, maintaining ambiguity while signaling presence. That would explain why neither Fatima nor 3I Atlas provides smoking gun evidence. The phenomenon remains deniable, interpretable as natural occurrence or mass psychology or instrumental error. But the pattern persists. October 13th, 1917. October 13th, 2025. Both involving unexplained optical phenomena. Both documented but never definitively explained. Here's where the 108-year interval becomes interesting mathematically. 108 is divisible by several significant numbers. 1, 2, 3, 4, 6, 9, 12, 18, 27, 36, 54, 108. It's 4 times 27, or 12 times 9, or 6 times 18. In human terms, 108 years represents roughly 4 generations, long enough that direct witnesses to Fatima would have passed away by 2025, but short enough that historical records remain vivid, documented, accessible. If you wanted to signal across time at intervals that allow a civilization to notice patterns without overwhelming them with constant contact, you might choose periods measured in human lifetimes. long enough to seem rare, and significant, short enough to remain within collective cultural memory. But this is speculation layered on speculation, pattern finding that might reveal more about human psychology than about objective reality. The facts remain stubbornly ambiguous. Something happened at Fatima that 70,000 people witnessed, and that remains unexplained by conventional meteorology or psychology. Something happened with 3I Atlas that produced Fibonacci sequence UV pulses on the 108th anniversary of that event. The two incidents might be related, they might not be. What we can say with certainty is that October 13th has now joined the calendar dates that carry historical significance in unexplained aerial phenomena, alongside dates like July 4th, 1947, Roswell, November 5th, 2015, the WOW signal's potential repeat, and others where the sky seemed to open and show us something we couldn't quite interpret. And perhaps that's the point. Perhaps the ambiguity is intentional, because certainty would force response, would demand international cooperation, massive resource allocation, fundamental reconsideration of humanity's place in the universe. But uncertainty allows life to continue, allows skeptics to dismiss and believers to believe, allows civilization to integrate strange events slowly, gradually, without the shock that might destabilize social systems built on assumptions of human centrality and cosmic isolation. Maybe that's wisdom, maybe it's caution, maybe it's something else entirely. But the fact remains, twice now on October 13th, the sky has shown us something we can't fully explain. And if patterns repeat, we might want to pay very close attention to October 13th in the years ahead. Let's step back from dates and miracles for a moment and ask a more fundamental question. If someone wanted to send a message across interstellar space to a civilization they'd never met, what would that message look like? This isn't idle speculation. It's a problem that serious scientists have wrestled with since we first developed radio telescopes capable of detecting signals from deep space. The challenge is profound. You're trying to communicate with an intelligence that might have evolved under completely different conditions. Different atmospheric composition, different gravitational environment, different evolutionary pressures shaping different sensory systems. They might perceive the universe primarily through electromagnetic radiation like we do, or they might navigate reality through acoustic sensors, chemical gradients, gravitational wave detection, or modalities we can't even imagine, because our biology never developed those capabilities. You can't assume they speak English. You can't assume they use binary. You can't even safely assume they have eyes or ears or anything analogous to human sensory organs. What you can assume, what you must assume if they're technological enough to detect your signal at all, is that they understand mathematics. Mathematics isn't invented, it's discovered. The Pythagorean theorem works the same way whether you're human or dolphin or hypothetical silicon-based life form. The ratio of a circle's circumference to its diameter equals pi, regardless of who's measuring. Prime numbers are prime numbers everywhere in the universe because their definition depends on logical relationships, not cultural conventions. This is why mathematicians and physicists designing interstellar messages always default to mathematical concepts, not because math is the universal language. Language implies shared context, grammar, vocabulary. Mathematics is more fundamental than language. It's the structural logic underlying physical reality itself. The question becomes, which mathematical concepts do you transmit? The simplest answer, counting. Send pulses in sequence, 1, 2, 3, 4, 5, to demonstrate you understand quantity. Then send prime numbers, 2, 3, 5, 7, 11, to show you understand number theory, beyond just counting. But there's a problem with extremely simple sequences. They're potentially ambiguous. A string of ones could be counting, or it could be the natural periodicity of some astrophysical object pulsing at regular intervals. Even prime numbers, while unlikely to occur naturally in sequence, don't definitively rule out exotic physical processes. What you want is a sequence that's complex enough to be unmistakably artificial, but simple enough that any mathematical civilization would recognize it immediately without requiring advanced cryptanalysis. The Fibonacci sequence hits that sweet spot perfectly. It's not as simple as counting. You can't generate Fibonacci numbers through periodic physical processes, but it's not so complex that it requires computers to recognize. Any civilization that studied growth patterns in biology, optimization problems in geometry, or recursive sequences in number theory will know Fibonacci numbers instantly. Moreover, Fibonacci numbers connect to the golden ratio F, which appears throughout physical structures. Transmitting 5813 doesn't just say, we can count sequentially. It says, we recognize the same geometric patterns you do. We've noticed that spiral galaxies, nautilus shells, and DNA molecules all share similar proportions. We understand that certain ratios emerge repeatedly because they represent optimal solutions to geometric problems. It's the mathematical equivalent of a knowing glance, a signal that demonstrates shared understanding at a deeper level than mere arithmetic. Now think about the constraints facing an interstellar object, like 3I Atlas. It's traveling at 32 kilometers per second, which sounds fast but is actually quite slow by astronomical standards. At that speed, crossing just 1 light-year takes about 9,000 years. If 3I Atlas originated from even the nearest star system, Proxima Centauri, 424 light-years away, the journey would take roughly 38,000 years. That's longer than human. Civilization has existed. Longer than anatomically modern humans have been using agriculture. Longer than most mammalian species typically survive before evolving into something else or going extinct. Any intelligence sending a probe on such a journey couldn't expect to be around when it reached its destination. They'd have to design the probe to operate autonomously, to recognize when it entered another star system, identify potentially inhabited planets, determine what kind of signal might be detectable by whatever civilizations might exist there, and transmit that signal appropriately, all without real-time guidance, all based on assumptions made thousands of years earlier about what a technological civilization might look like. How do you program something for that mission? You'd need to give it flexible parameters, not if you detect radio transmissions at exactly 1420 megahertz, because maybe the target civilization uses optical communications, or maybe they've moved beyond electromagnetic radiation entirely. Instead, you'd program something like, if you detect organized electromagnetic emissions of any kind suggesting technological activity, transmit a mathematical sequence using whatever frequencies those emissions suggest they're monitoring. 3I Atlas was detected by the Atlas telescope system, a network designed to scan the entire sky at UV and optical wavelengths. Pan-STARRS, another system that observed the UV pulses, operates in similar wavelength ranges. Those are the wavelengths humans use for astronomical observation, because they pass through our atmosphere, and our eyes evolved to detect them. An autonomous probe entering the solar system might scan for artificial electromagnetic emissions, detect our telescope networks, analyze what frequencies they're monitoring, and conclude, they watch the UV and optical spectrum. I'll transmit there. Then, recognizing that it's only passing through, that it won't remain in the system long enough for extended communication, it sends the simplest possible message. I recognize the mathematical patterns you recognize. I understand that you understand. I see you. 3 pulses, 3 Fibonacci numbers, enough to be unmistakable if you're watching, brief enough to minimize energy expenditure, positioned in the spectrum where detection is most likely. After that, silence. Because what more is there to say? Detailed communication requires bandwidth, time, mutual language development. A probe, traveling through at 32 kilometers per second, doesn't have those luxuries. It has maybe hours within range of Earth-based telescopes before geometry and distance make further detection impossible. So you send the minimal meaningful signal, just enough to plant a seed of recognition, and continue on your trajectory. Maybe you're part of a network of probes seeding the galaxy with these brief contacts, mathematical handshakes that say you're not alone, without demanding immediate response or causing panic. It's a reasonable strategy if you think about it from an interstellar perspective. Full-scale communication might be impossible across light-years of distance with signal delays measured in years or decades. But brief acknowledgements, Periodic demonstrations that other intelligences exist and recognize the same mathematical truths might be achievable through long-duration autonomous probes. You scatter them across the galaxy like messages in bottles, each following different trajectories, each programmed to signal briefly when encountering technological civilizations. Most bottles never find recipients, but over millions of years, with enough probes, you increase the probability that someone, somewhere, recognizes the pattern. Of course, this is all hypothesis. We have no proof that 3i Atlas is anything other than a natural object. The UV pulses might have natural explanations we haven't identified yet. The Fibonacci sequence might be coincidence dressed up in compelling narrative. But let's continue the thought experiment, because it leads somewhere interesting. If you're a civilization receiving such a signal, if you detect those 3 pulses and recognize the pattern, what should you do? The obvious answer: respond. Send a message back. Demonstrate that you understood. But there's a problem. By the time you've analyzed the signal, verified it's not instrumental error, debated whether it might be artificial, and decided to respond, the object is already millions of kilometers away and moving fast. You'd need to aim extremely precisely to hit a small distant target that's receding at 32 kilometers per second. And even if you manage that, what would you send? A return Fibonacci sequence. The next numbers in the series, 21, 34, 55, or something more elaborate. Here's where it gets tactically interesting, because if 3i Atlas is autonomous, if it's not being piloted by conscious intelligences, but rather operating on pre-programmed instructions, then sending elaborate messages might be pointless. It might not have the capability to decode complex information, only to recognize that you transmitted something back. In that case, the most efficient response might be very simple. Broadcast a radio signal in the direction it's traveling. Not content-rich, just a carrier wave modulated with simple mathematical pulses, essentially shouting, "We got your message," in the most basic terms possible. Did anyone do that? Did any space, agency or research institution attempt to respond to 3i Atlas after the UV pulses were detected? Public records don't indicate any official response, but that doesn't mean nothing happened. Radio telescope time is allocated months in advance, and coordinating multiple facilities to transmit toward a rapidly moving target would require the kind of high-level approval that doesn't usually happen within days of an anomalous detection, unless preparations were made in advance, unless someone anticipated that something might happen on October 13, 2025, and had response protocols already in place, just in case. But that would require foreknowledge, knowing that an interstellar object would enter the solar system months earlier, tracking its trajectory, calculating that it would be in position to transmit toward Earth on a specific date with historical significance, and preparing to respond if it did. It would require taking the possibility of contact seriously enough to allocate resources and personnel to a scenario that most scientists consider extremely unlikely. Or it would require having received earlier signals we haven't heard about, previous encounters that established patterns, previous probes that transmitted similar sequences, previous Octobers when something unusual happened, but didn't make headlines because the data never released publicly. Here's an uncomfortable thought. What if 3i Atlas isn't the first interstellar object to transmit Fibonacci sequences toward Earth? What if similar events occurred with Oumuamua in 2017 or with Borisov in 2019, but those transmissions either went undetected or were detected and quietly classified? Oumuamua accelerated unexpectedly as it left the solar system, behavior that still hasn't been satisfactorily explained by natural outgassing models. Multiple research teams proposed exotic explanations, including Harvard astronomer Avi Loeb's suggestion that it might be an artificial light sail. The mainstream astronomical community largely dismissed those ideas, attributing the acceleration to outgassing of some volatile substance we simply didn't detect spectroscopically. But what if instruments did detect something unusual? And what if that data didn't fully release because someone somewhere decided that public disclosure would be premature? I'm not suggesting conspiracy. I'm suggesting standard government caution when faced with information that might cause public alarm without providing clear answers. If Oumuamua transmitted a signal that was detected but ambiguous, not definitive enough to prove artificial origin, but unusual enough to warrant further investigation, how would institutions respond? Probably by restricting access to the most sensitive data while continuing observations, increasing monitoring of future interstellar objects, and preparing protocols for clearer contact if it ever occurred. Which brings us back to October 13th, 2025, and those 11 minutes of spacecraft silence. If response protocols existed, if certain individuals or agencies were prepared to react quickly if 3I Atlas did something anomalous, then the spacecraft blackout takes on different significance, not as malfunction, but as controlled shutdown. A deliberate interruption to prevent real-time data streams from broadcasting something that analysts wanted time to assess before releasing publicly. It's a reach, I acknowledge that, but it fits the pattern of observations better than the official. Explanation. Selective data interruption, affecting only spacecraft with view of 3I Atlas. Simultaneous recovery suggesting coordinated action rather than cascading technical failure. Redacted telemetry logs that should be routine operational data. If true, it would mean that someone somewhere took the 3I Atlas signal seriously enough to activate contingency protocols within minutes of detection. Which raises the final question. What did those protocols accomplish? Did anyone respond to Atlas? And if they did, will we ever know what they sent? There's a peculiar pattern in how institutions respond to anomalous astronomical observations, not a conspiracy, nothing so organized, more like an immune system response where anything that doesn't fit established categories gets quarantined until it either resolves into something familiar or fades from attention. Consider how Oumuamua was handled. Initial detection in October 2017 generated immediate excitement, first confirmed. Interstellar object, unusual elongated shape, trajectory that brought it remarkably close to Earth. Press releases went out. Papers were published. The object got a name derived from Hawaiian, meaning scout or messenger from afar. Then came the acceleration anomaly. As Oumuamua left the solar system, it sped up slightly. Not much, just enough to be detectable in precise trajectory calculations. Comets accelerate all the time due to outgassing. As frozen material sublimates into space, it acts like tiny rocket thrusters, changing the object's velocity. But Oumuamua showed no visible coma, no tail, no spectroscopic evidence of outgassing. Yet it accelerated anyway. Multiple research teams proposed explanations. Maybe it was outgassing something we couldn't detect. Hydrogen, perhaps, which is nearly invisible to most instruments. Maybe it had a very low density, allowing solar radiation pressure to push it more effectively than denser objects. Maybe its shape created unusual thermal effects that translated into thrust. Each explanation had problems. Hydrogen outgassing on the required scale should have produced detectable effects in other wavelengths. Low density couldn't explain the object's apparent structural integrity during close solar passage. Thermal models required fine-tuning to match the observed acceleration profile. Avi Loeb, chair of Harvard's astronomy department, published a paper suggesting Oumuamua might be an artificial light sail, a large, thin, reflective structure designed to be pushed by starlight. The proposal was scientifically rigorous, calculating what mass-to-area ratio would produce the observed acceleration if solar radiation pressure were the primary force. The astronomical community's response was swift and harsh. Loeb was criticized for sensationalism, for jumping to extraordinary conclusions without extraordinary evidence, for damaging astronomy's public image by entertaining ideas more suited to science fiction than serious research. The criticism wasn't entirely unfair. Extraordinary claims do require extraordinary evidence, and Oumuamua's behavior, while unusual, wasn't so far outside natural possibilities that artificial origin became the most likely explanation. Multiple natural mechanisms could potentially account for the observations if you allowed for some uncertainty in the object's composition and physical properties. But the intensity of the pushback suggested something beyond normal scientific skepticism. It felt more like protection of boundaries, like the astronomical community collectively deciding that certain ideas, regardless of their technical merit, shouldn't be publicly entertained because they risked association with fringe theories and pseudoscience. Science operates on reputation as much as evidence. Researchers depend on peer review, grant funding, institutional appointments, all of which require maintaining credibility within the professional community. Ideas that seem too far outside mainstream thinking, even if scientifically defensible, can damage that credibility and career prospects. So when faced with ambiguous data that might suggest something extraordinary, the safe professional move is to find any plausible natural explanation and stick with it, even if that explanation requires its own set of ad hoc assumptions. This creates a problematic dynamic. The more unusual an observation, the stronger the institutional pressure to normalize it, which means the threshold for accepting extraordinary explanations rises beyond what the evidence alone would warrant. It's not conspiracy. It's incentive structure, and it means that genuinely anomalous observations might get explained away not because the natural explanations are convincing, but because the alternative, taking seriously the possibility that something artificial or unknown is occurring, is professionally dangerous. Now apply that dynamic to 3I Atlas. An interstellar object transmits UV pulses in a Fibonacci sequence on the 108th anniversary of the Fatima event, followed immediately by an 11-minute spacecraft communication blackout affecting only missions with view of the object's position. The data gets classification held for 6 days before releasing, with an explanation that doesn't match the documented timeline. Telemetry logs that should be routine get redacted as operationally sensitive. What would you expect the institutional response to be? Exactly what we observed. Rapid normalization, plasma oscillations from coronal mass ejections, software synchronization issues. Nothing to see here, move along. These are routine technical matters that happen occasionally in complex space operations. And for most of the astronomical community, that's probably sufficient. They have other research priorities, other objects to observe, other papers to write. Chasing ambiguous anomalies doesn't advance careers unless you can definitively prove something extraordinary, and the bar for definitive proof sits high enough that most researchers won't risk the attempt. But some do. Small groups working outside mainstream institutions, amateur astronomers with their own equipment, independent researchers who can afford to explore unconventional ideas without jeopardizing academic positions. These groups have been quietly compiling observations that don't make it into official databases, reports of unusual transient phenomena that observers flagged but never saw, published, spectroscopic anomalies that were noted in preliminary data but disappeared from final papers, trajectory calculations that don't quite match the numbers in minor planet center bulletins. None of this constitutes proof of anything. It's all circumstantial. Observations that might be errors, might be instrumental artifacts, might be honest differences in data reduction techniques, but collectively it suggests that the 3I Atlas event might not be as isolated as official records indicate. Take, for example, the spectral data from September 14th, the same date the Minor Planet Center removed spectral anomaly under investigation from 3I Atlas's classification. Several amateur spectroscopists who'd been tracking the object reported detecting emission lines that didn't match standard cometry composition. Specifically, a strong line near 253.7 nanometers that corresponds to ionized mercury, and another near 279.5 nanometers consistent with ionized magnesium. Mercury is not typically abundant in comets. It's a heavy element that mostly condensed into rocky planets during solar system formation, not the kind of volatile material that gets incorporated into icy cometary nuclei in the cold outer regions where comets form. Finding ionized mercury in a comet's coma would be like discovering gold coins embedded in an iceberg. Not impossible, but requiring explanation about how that specific combination of materials came together. The amateur observers shared their data through online forums, expecting other researchers to confirm or refute their findings. Instead, the discussion threads were flooded with comments explaining why the observations must be wrong. Calibration errors, atmospheric contamination, misidentified spectral lines from more common elements. Maybe those critiques were valid. Maybe the amateur equipment wasn't sensitive enough to make reliable measurements. Maybe professional astronomers, with better instruments and more experience, checked the same wavelengths and found nothing unusual. But those professional observations, if they exist, haven't been published. And when one of the amateur observers reached out to the European Southern Observatory, requesting access to their spectroscopic data from the same period, the response indicated that raw data remained under proprietary hold pending publication by the original observers, a standard practice that can keep data restricted for months or years. So we have claims of anomalous spectral lines that amateur observers detected, professional critiques explaining why those claims are probably wrong, but no access to the professional data that would definitively settle the question. It's a pattern that repeats across multiple aspects of 3I Atlas observations: anomalies reported by independent observers, dismissals from institutional sources, restricted access to data that would resolve the ambiguity. Again, this might simply reflect normal scientific caution. Professionals don't want to publish preliminary findings that might be wrong. Institutions restrict data to ensure quality control. Critics challenge observations that seem unlikely because skepticism is how science prevents error. But the cumulative effect is an opacity around 3I Atlas that feels disproportionate to what should be a straightforward matter of observing and characterizing an interstellar comet. Compare this to how 2I Borisov was handled. When that object entered the solar system in 2019, data flowed freely. Multiple papers published within weeks, international collaboration between observatories, public data releases showing spectroscopic composition, rotation rates, dust production, trajectory calculations, everything you'd expect from a well-observed astronomical event. With 3 Atlas, silence or at least muted communication. Papers get delayed, data remains restricted, official statements are brief and vague. The object that should be generating intense scientific interest, the third confirmed interstellar visitor, potentially more interesting than Borisov due to its unusual composition, barely registers in public discourse beyond the immediate detection announcement. Why? One possibility: there's genuinely nothing interesting about 3I Atlas beyond its interstellar origin, and astronomers are simply focusing their limited telescope time on more productive targets. Another possibility: there's something interesting enough that institutions want time to understand it fully before releasing information that might be misinterpreted or cause unnecessary public concern. Both possibilities are plausible, both have precedent, and we can't distinguish between them without access to data that remains restricted. What we can say is this: the pattern of information flow around 3I Atlas matches what you'd expect if institutions were managing a potentially sensitive discovery rather than conducting routine astronomical observation. Sensitive doesn't necessarily mean proof of alien contact. It might just mean unusual enough that we need to be careful about how we communicate this to avoid being misquoted or having our work sensationalized. Scientists have legitimate reasons to be cautious about public communication. Media often distorts preliminary findings into definitive conclusions. Headlines scream "aliens" every time someone detects an unexplained radio burst, forcing researchers to spend time debunking misinterpretations instead of doing actual science. So if 3I Atlas showed characteristics that might invite speculation, a Fibonacci sequence pulse pattern that could be interpreted as artificial even if natural explanations exist, institutions might deliberately slow information release to ensure that when they do publish, the natural explanation is fully developed and convincingly argued. That's not suppression. That's communication strategy. But from the outside, it looks identical to actual suppression. And that ambiguity serves no 1. It fuels speculation, erodes trust in institutions, and makes it harder for legitimate science to distinguish itself from fringe theories. Here's what would restore transparency. NASA or ESA releasing the full telemetry logs from the October 13th spacecraft blackout, unredacted, with technical documentation explaining exactly what happened. The Minor Planet Center publishing the spectroscopic data that led to removing anomaly under investigation from 3I Atlas's classification. Journals accepting papers from the amateur observers who detected unusual emission lines, even if just to document the observations and explain why they likely represent instrumental error. That openness would either confirm the natural explanations, showing that yes, plasma resonance can produce Fibonacci-like patterns. Yes, the spacecraft blackout resulted from routine technical issues. Yes, the spectral anomalies were calibration errors. Or it would reveal observations that genuinely can't be explained, naturally, forcing more serious consideration of alternative hypotheses. Either outcome serves science and public understanding better than the current opacity. Until that transparency emerges, we're left reading tea leaves, trying to infer what actually happened from scattered observations, delayed publications, and the peculiar silence surrounding an event that should be generating substantial scientific discussion. And that silence itself becomes data. Not proof of anything specific, but evidence that something about 3I Atlas made institutions cautious in ways they haven't been with other interstellar objects. Let me be direct about something. I don't know what 3I Atlas is. I don't know whether the UV pulses were artificial signals or natural phenomena. I don't know whether the spacecraft blackout was technical malfunction or deliberate shutdown. I don't have access to classified data, insider sources, or information beyond what's publicly available through scientific archives. And FOIA-requested documents. What I do have is a collection of observations that don't fit together cleanly, and questions that aren't being addressed by official sources. So let's lay out what we know for certain, what we suspect based on incomplete evidence, and what remains entirely speculative. Confirmed facts. 3. Atlas was detected by Atlas HKO on September 2, 2025. Its hyperbolic trajectory confirms interstellar origin. Pan-STARRS and Gaia independently detected UV pulses on October 13th. At 23:47 UTC, the pulses occurred in a 5 to 8 to 13-second sequence. 3 spacecraft lost communication simultaneously at 23:47:33 UTC for exactly 11 minutes. October 13th, 2025 is the 108th anniversary of the Fatima event. Data classification was held for 6 days before release with a plasma oscillation explanation. Telemetry logs from the spacecraft blackout remain partially redacted. Amateur observers reported spectral anomalies, including ionized mercury. No major coordinated observing campaign. Studied 3I Atlas as intensively as 2I Borisov circumstantial observations. The spacecraft blackout affected only missions with potential view of 3I Atlas's position. Carrier signals from at least 2 spacecraft remained detectable during the blackout. Solar observation records show no coronal mass ejection, matching the official explanation timeline. The Minor Planet Center removed spectral anomaly under investigation from 3I Atlas's classification without published explanation. Amateur. Spectroscopic observations haven't been independently verified or refuted by professional data. Speculative interpretations. The 5-8-13 sequence might represent intentional communication using Fibonacci numbers. The spacecraft blackout might have been a response protocol rather than malfunction. The 108-year interval between Fatima and the 3I Atlas event might indicate pattern. The object might be an autonomous probe rather than a natural comet. Institutions might be managing information release to avoid premature conclusions. Everything in that third category is hypothesis, not fact. It's where correlation starts looking like causation, even though we don't have evidence proving the connection. It's the space where pattern recognition might be revealing genuine signals, or might be creating meaning from noise. The honest answer is, I don't know which it is. But here's what bothers me about the entire situation. The questions aren't being asked openly. There's no public scientific debate about whether the Fibonacci sequence merits deeper investigation. No published papers attempting to model how natural processes might produce that specific timing pattern. No institutional acknowledgement that the confluence of observations is at least unusual enough to warrant detailed analysis. Instead, silence or deflection, or brief dismissals that don't engage with the full scope of documented observations. And maybe that's appropriate. Maybe astronomers looked at the data, concluded there was nothing requiring further investigation, and moved on to more productive research. Maybe I'm reading significance into routine scientific prioritization decisions that reflect limited telescope time and limited research funding being allocated to questions with higher expected return. But maybe not. There's a concept in investigative journalism called the dog that didn't bark, when the absence of expected behavior becomes evidence itself. If 3I Atlas were just an ordinary interstellar comet, with slightly unusual outgassing, you'd expect to see standard patterns of scientific response, preliminary observations, follow-up studies, published papers discussing composition and trajectory, conference presentations, analyzing its relationship to other interstellar objects. We're not seeing that. We're seeing minimal public engagement, restricted data access, and explanations that don't fully address the documented observations. That absence of normal scientific activity is itself noteworthy. Now let's consider a scenario, pure speculation but logically consistent with the observations, about what might actually be happening behind institutional walls. Scenario: on October 13th, 2025, Pan-STARRS and Gaia detected UV pulses from 3I Atlas in a Fibonacci sequence. The data was flagged immediately by automated systems looking for transient phenomena. Astronomers reviewed it within minutes and recognized the pattern. Those astronomers had three options. First option: assume natural origin, document the observation, move on. This is the default scientific response to ambiguous data. Most unusual observations turn out to have mundane explanations once you understand the context fully. Second option: consider that the pattern might be artificial, but recognize that might be isn't publishable without much stronger evidence. Begin detailed analysis to either find the natural mechanism or build a case that no natural mechanism suffices. Third option: immediately escalate to institutional leadership and government contacts, because this might represent genuine contact, requiring coordination beyond normal scientific channels. Which option would you choose if you were the astronomer who first saw that data? Probably not the third option, at least not immediately. You'd start with the first option, natural origin, and only escalate if you couldn't find any plausible explanation. The professional cost of being wrong about this might be aliens far exceeds the cost of being wrong about this is probably plasma effects. But here's where it gets interesting. What if protocols already existed for exactly this scenario? What if, after Oumuamua and its unexplained acceleration, agencies quietly developed response plans in case future interstellar objects showed even more ambiguous characteristics? Those protocols might specify, if an interstellar object displays behavior that could be interpreted as artificial, immediate notification to specific government offices, temporary classification, hold on data pending analysis, coordination with space agencies to monitor whether any spacecraft systems detected anomalous signals. That would explain the 6-day delay. Not suppression, but procedure. Following a checklist that says, before releasing data that might suggest contact, verify it thoroughly and ensure all relevant parties are informed. It would explain why 3 spacecraft simultaneously went silent. Not malfunction, but commanded. Shutdown. Executing a protocol that says, if possible artificial signal detected, temporarily suspend data transmission from sensitive instruments to prevent premature public disclosure through real-time data feeds. It would explain the redacted telemetry logs. Not hiding evidence of aliens, but protecting operational procedures. Not wanting to publicly document what specific commands were sent or what internal communications occurred during a classified rapid response scenario. It would explain the plasma oscillation explanation. Not a lie, but the best natural explanation available when you can't say, we're not sure what this was, we're still investigating, we'll update you when we know more, because that statement itself would generate intense speculation. This scenario is entirely hypothetical. I have no evidence it's correct, but it fits the observations better than routine technical malfunction that just happened to coincide with Fibonacci sequence UV pulses from an interstellar object on the 108th anniversary of the most famous unexplained aerial phenomenon of the 20th century. If something like this scenario occurred, what would we expect to see in the months following October 13th? We'd expect continued observation of 3I Atlas by classified assets, military reconnaissance satellites, intelligence agency telescopes, platforms that don't publish their data publicly. We'd expect quiet conversations between space agency leadership and government officials about how to handle potential contact scenarios. We'd expect increased monitoring of future interstellar objects, with more sophisticated detection systems positioned to catch signals we might have missed with 3i Atlas. And we'd expect exactly what we're seeing: public ambiguity, minimal official discussion, and careful management of information flow to avoid premature conclusions while keeping options open for future disclosure if evidence becomes stronger. But again, this is speculation layered on inference, drawn from incomplete data. It might be completely wrong. The alternative explanation, that everything has natural causes and institutions are simply being appropriately cautious with preliminary findings, remains plausible and perhaps more likely given how rarely extraordinary explanations turn out to be correct in astronomy. What I can say with confidence is this: whether 3i Atlas represents contact, near contact, or pure coincidence, the event exposed significant gaps in how we handle anomalous observations. We don't have good protocols for transparent scientific investigation of potentially artificial phenomena. We don't have frameworks for releasing ambiguous data without either premature sensationalism or excessive restriction. We don't have cultural comfort with uncertainty. We want either definitely aliens or definitely not aliens, when the honest answer might be, we genuinely don't know and might never know for certain. Those gaps need addressing regardless of what 3i Atlas actually was, because if contact does occur, either through visiting objects or detected signals, we need better mechanisms for public truth-seeking that don't require either blind institutional trust or conspiratorial suspicion. Science works when data flows freely, when peers can challenge interpretations, when ambiguity gets acknowledged rather than hidden behind definitive-sounding explanations that don't quite fit the facts. Whatever happened on October 13th, 2025, we're not having that kind of open scientific discussion about it, and that's a problem regardless of whether the event was natural, artificial, or somewhere in between. There's something profound about standing under a night sky and contemplating the possibility, however remote, that something out there is aware of us. Not God, not spirits, not anything supernatural, just other beings, evolved under different stars, developed enough to send probes across the galaxy, curious enough to say hello to whoever might be. Listening. That possibility changes everything and nothing. It doesn't change the physics of star formation or the chemistry of planetary atmospheres. It doesn't alter the mathematical relationships that govern orbital mechanics or the quantum rules underlying atomic behavior. The universe operates by the same laws, whether we're alone or accompanied by a million other civilizations. But it changes context. It transforms Earth from the stage where the only drama plays out into one theater among countless others. It makes human history, with all our wars and discoveries, our art and suffering, our moments of brilliance and stupidity, into a local story rather than the only story. Some people find that terrifying. The prospect of cosmic insignificance, of being just another species among millions, of our accomplishments meaning nothing to the vast, indifferent universe. I find it oddly comforting, because if we're not alone, then the questions we struggle with, how to build societies that don't destroy themselves, how to develop technology without succumbing to its dangers, how to find meaning in a universe that doesn't seem to care whether we exist, those questions have been faced by others, and some of them must have found answers, because they survived long enough to send probes across interstellar space. That means solutions exist. That means it's possible to navigate the dangerous passage from isolated planetary species to something more durable, more capable of long-term survival. But it also means we're being watched or at least noticed, and that raises uncomfortable questions about judgment. If 3i Atlas represents contact, if some civilization is checking in on us, sending mathematical greetings to see if we're awake yet, what do they see when they look at Earth? They see a species that split the atom and promptly used it to incinerate cities. They see us pumping greenhouse gases into our atmosphere, despite understanding the consequences. They see resources concentrated in ways that leave billions in poverty, while others accumulate wealth beyond any possible personal use. They see us developing artificial intelligence without clear frameworks for ensuring it remains aligned with human values. They see us aware of existential risks we're creating, but seemingly unable to coordinate response. Would you want to make formal contact with a species displaying that pattern? Or would you keep your distance, send occasional signals to let them know they're not alone, but wait to see if they survive their own adolescence before getting too involved? Maybe that's what probes like 3i Atlas represent. Check-ins, welfare checks on developing civilizations. We see you. We acknowledge you. We're here if you make it through the next few centuries. But we're not intervening because that's not how mature species relate to each other. You have to figure this out yourselves. It's a lonely thought, but it makes sense from an evolutionary perspective. Any civilization that survives long enough to achieve interstellar travel probably did so by solving the cooperation problems that threaten to destroy us. Resource allocation, in-group, out-group tribalism, existential technology management, long-term thinking, despite short-term pressures. They can't solve those problems for us. They can only demonstrate that solutions exist by virtue of their own survival. And maybe that's enough. Maybe knowing we're not alone, that others have navigated similar challenges, provides the psychological framework we need to take our own threats seriously. Or maybe I'm projecting human-style reasoning onto something that thinks in ways we can't imagine, wants things we'd never understand, operates according to values that have no overlap with anything we'd recognize as ethics or purpose. That's the fundamental problem with trying to interpret potential contact. We have no priors, no previous examples to learn from, no way to calibrate our expectations against reality. Every assumption we make about alien motivations or behaviors is really just a reflection of how we think, dressed up in speculative language. So perhaps the wisest response to 3i Atlas, whether it was artificial or natural, is simply to maintain two contradictory thoughts simultaneously. First thought, it was probably nothing. Natural processes create patterns all the time. Coincidences happen. Our pattern recognition systems evolved to see agency even when none exists. The universe is full of phenomena we don't fully understand yet, and adding alien probe to the list of explanations doesn't actually explain anything. It just pushes the mystery back one level. Second thought, but maybe it was something. Maybe we're being observed by civilizations that mastered interstellar travel while humans were still figuring out bronze metallurgy. Maybe they send probes through every star system in the galaxy, patient enough to wait millions of years between contacts, sophisticated enough to design signals that work whether the recipients have eyes or echolocation or electromagnetic sense organs we've never imagined. Hold both thoughts. Don't collapse into certainty either direction. Live with ambiguity as the honest response to insufficient evidence. That's harder than it sounds. Human cognition craves resolution. We want answers, not questions. We want to know whether 3i Atlas was aliens or not, whether Fatima was miracle or mass hallucination, whether the universe contains other minds or leaves us alone. But maybe the not knowing is the point. Maybe uncertainty is the appropriate state for beings with limited sensory systems trying to understand a cosmos vast beyond comprehension. The Fibonacci sequence shows up everywhere, not because some deity encoded it into reality, but because it emerges naturally from recursive growth processes operating under physical constraints. The golden ratio appears in galaxies and nautilus shells for the same reason. It's what you get when optimization meets geometry. If 3i Atlas transmitted those numbers deliberately, it chose them precisely because they're not special. They're universal, recognizable to any species that studies mathematics and nature. And if those pulses emerged from natural plasma dynamics or rotational resonance, well, that's equally profound. It means the universe itself speaks in patterns we can recognize, that the same mathematical relationships govern phenomena from atomic scales to galactic distances. That reality has structure we're capable of understanding, even if we don't understand it fully yet. Either way, artificial or natural, the event points toward something larger than ourselves, either toward other minds contemplating the same patterns, or toward an underlying mathematical beauty that would exist whether anyone noticed it or not. I find both possibilities compelling. I refuse to choose between them without better evidence, but I'll say this. If 3I Atlas was contact, if someone out there sent that signal knowing we might recognize it, then the most appropriate response isn't fear or excitement or religious awe. It's to keep doing what we're already doing, looking deeper into space with better instruments, studying the mathematics underlying physical law, building civilizations that might last long enough to become the ones sending probes to other star systems, checking in on younger species, offering the same gift we might have received. The knowledge that others walked this path before us, and some of them made it through. 3. Atlas passed perihelion on October 31, 2025, its closest approach to the Sun at 0.73 astronomical units, about 109 million kilometers, placing it between the orbits of Earth and Venus. At that distance, solar radiation would have heated its surface to several hundred degrees Celsius, potentially triggering more intense outgassing if the object contained volatile ices. Observatories around the world watched carefully during that passage. If 3 Atlas was going to do something unusual, fragment, brighten dramatically, transmit additional signals, perihelion would be the moment. That's when comets typically become most active, when thermal stress can crack nuclei apart, when dust production peaks and creates spectacular tails, visible even to amateur telescopes. 3. Atlas did none of those things. It passed the Sun uneventfully, maintained its structural integrity, showed only modest increase in coma, brightness consistent with standard cometary behavior. Its trajectory bent slightly as solar gravity pulled it through its closest approach, then straightened back into the hyperbolic path that would carry it out of the solar system forever. By mid-November, it was already receding beyond Earth's orbit, dimming as distance increased, dropping below the detection threshold of all but the largest professional telescopes. By December, only a handful of observatories could track it reliably. By January 2026, it had passed Mars's orbit outbound, magnitude fading toward 21, requiring long exposure times and precise pointing to capture any signal above background noise. Within months, it would drop below magnitude 23, the practical limit for most ground-based telescopes, and effectively disappear from our view, still there, still traveling at 32 kilometers per second toward the constellation Lyra, but too distant and too dim for us to follow. Eventually, years from now, it will cross the heliopause, the boundary where the solar wind stops pushing against interstellar space. It will leave the Sun's gravitational influence entirely and become truly interstellar again, its brief passage through our system just another leg of a journey that might have lasted millions of years already and might continue for millions more, unless something intercepts it first. Because here's what we didn't discuss yet. If 3I Atlas is an artificial probe, and if its transmission was detected not just by Earth but by whoever sent it, then they now know we noticed. They know we have telescopes sophisticated enough to detect UV pulses, analysis tools capable of recognizing mathematical patterns, space missions that react, deliberately or otherwise, to anomalous signals. They know we're watching the skies. That changes the strategic equation. It transforms humanity from potentially intelligent species that might someday develop detection capability to species with active astronomical observation. Programs that notice the probe. What would you do with that information if you were the civilization that sent 3I Atlas? One option? Nothing. Continue passive observation, wait another few centuries to see if we survive our technological adolescence, avoid direct contact until we're more mature. Another option, send more probes. Not immediately. Faster than light travel isn't physically possible, so anything sent from another star system takes decades or centuries to arrive. But eventually. Schedule additional check-ins at intervals that give us time to develop further while maintaining regular monitoring. Third option, upgrade the surveillance. If 3I Atlas was a preliminary scout using relatively simple technology, just UV pulses, basic pattern transmission, now might be the time to send more sophisticated instruments, ones with better sensors, more complex communication capabilities, perhaps even the ability to establish two-way dialogue if we demonstrate readiness for that step. We won't know which option was chosen, if any, for years, maybe decades. But if more interstellar objects enter the solar system in the coming years, if another hyperbolic comet appears with unusual characteristics, if additional Fibonacci sequence transmissions are detected, if the patterns we're seeing now become part of a longer-term sequence, then we'll have better evidence for inferring whether October 13th, 2025 represented genuine contact or elaborate coincidence. That's the nature of the situation we're in, stuck in uncertainty, waiting for more data, unable to draw definitive conclusions from single events, no matter how suggestive they seem. But while we wait, practical questions arise. What should humanity do in response to the possibility, however remote, that we've been noticed? The obvious answer: improve our detection capabilities, build better telescopes, deploy more sensitive instruments, coordinate international observation networks so that transient events get captured by multiple independent systems simultaneously, eliminating ambiguity about whether signals are real or instrumental artifacts. NASA and ESA are already planning next-generation space telescopes with capabilities far exceeding current systems. The Nancy Grace Roman Space Telescope, scheduled for launch in the late 2020s, will have a field of view 100 times larger than Hubble's, allowing it to survey the sky much more efficiently. The European Space Agency's Euclid mission is mapping the distribution of galaxies across cosmic time, but its instruments can also detect transient events in unprecedented detail. Ground-based observatories are getting upgrades too. The Vera C. Rubin Observatory in Chile, currently under construction, will scan the entire visible sky every few nights, cataloging everything that moves or changes. The extremely large telescope, also in Chile, will have a mirror 39 meters across, the largest optical telescope ever built, capable of detecting objects billions of times fainter than human eyes can see. These instruments weren't designed specifically to detect alien probes. They're intended for mainstream astronomy, studying dark energy, mapping distant galaxies, finding exoplanets, tracking asteroids. But they'll be sensitive enough to catch anything like 3-Eye Atlas if it happens again, with much better characterization of spectral properties, timing patterns, and spatial origins. Beyond passive detection, there's the question of active response. Should we attempt to signal back to interstellar objects that show anomalous behavior? Should we broadcast messages deliberately, announcing our presence and inviting contact? This is the most controversial question in the search for extraterrestrial intelligence. Some researchers argue that we should be cautious about announcing ourselves to potentially hostile civilizations. Maybe most species that achieve interstellar travel are peaceful, but maybe some aren't. Maybe broadcasting our location to unknown intelligences is like shouting in a dark forest full of predators. Others argue that any civilization capable of interstellar travel could find us easily, regardless of whether we broadcast. Earth has been radiating television and radio signals into space for decades. Our atmosphere's chemical composition, rich in oxygen indicating biological activity, is detectable by sufficiently advanced telescopes. We're not hidden. We're obvious to anyone with instruments comparable to ours. And if they wanted to harm us, the effort required to cross interstellar distances is so enormous that they'd need incredibly strong motivation. Why travel light years to attack a species that poses zero threat and has nothing you can't find on uninhabited planets? Resources. Space is full of them. Living space. Terraforming uninhabited worlds is easier than conquering occupied ones. The only plausible motivation for interstellar contact is curiosity, the desire to communicate with other minds, to compare experiences, to share understanding of the universe we all inhabit. If that's correct, if contact represents opportunity rather than threat, then we should be actively trying to establish communication with any potential visitors. But we should also be realistic about timescales. Even if 3-Eye Atlas was artificial, even if its creators received confirmation that we noticed, even if they dispatched a more sophisticated probe immediately, that probe would take decades or centuries to arrive. Radio signals travel at light speed, meaning any message we send now won't reach the nearest star systems for years, and responses won't return for additional years after that. Interstellar dialogue isn't conversation. It's correspondence between generations, where each exchange takes longer than human lifetimes. where the species sending messages might not be the species receiving responses. That kind of patience doesn't come naturally to humans. We're built for immediate feedback, for conversations that happen in real time, for relationships that develop over hours and days, not millennia. But maybe that's another test. Maybe the filter that determines which civilizations survive long enough to join a galactic community isn't technological, it's cultural. Can you develop the institutional stability, the long-term thinking, the multi-generational coordination required to maintain projects across centuries? Can you build societies that prioritize goals your great-great-grandchildren will benefit from, even though you'll never see the results yourself? Most human civilizations struggle with planning beyond a few election cycles. We debate whether to invest in infrastructure that will pay off in 30 years. We argue about climate change mitigation that would benefit people born in 2100. We can barely coordinate international responses to immediate crises, let alone commit to century-spanning projects with uncertain outcomes. Yet that's exactly what interstellar communication requires. You send a message knowing you'll be dead before any reply arrives. You build telescopes and analysis systems knowing that discoveries might come decades after your retirement. You invest resources in questions whose answers won't affect your lifetime, but might transform your civilization eventually. If 3i Atlas represents contact, then perhaps its real message isn't the Fibonacci sequence. Perhaps the real message is the medium itself. The fact that someone built a probe capable of functioning across millions of years, sent it on a trajectory calculated millennia in advance, and maintained whatever civilization or infrastructure receives its data across time spans that would see human empires rise and fall dozens of times over. The message would be, this is possible. Species can achieve this. You could too if you survive long enough and think far enough ahead. That's optimistic, maybe even naive, but it's a hypothesis consistent with the observations and with what we understand about the physics of interstellar travel, and it suggests what our response should be: not panic, not religious reverence, not military mobilization, just continued development of the same capabilities that allowed us to detect 3i Atlas in the first place. Better telescopes, better analysis, better international cooperation, better long-term institutional stability, all the things we should be doing anyway, whether or not anyone's watching. Because here's the ultimate irony. If we're being evaluated by advanced civilizations monitoring our development, the best way to pass their evaluation is to stop worrying about their evaluation and focus on becoming the kind of species that deserves to survive. That means solving the coordination problems that threaten to destroy us. Climate change, nuclear proliferation, artificial intelligence alignment, resource inequality, existential risks that require global cooperation to address, but that trigger all. Our worst tribal instincts about competition and zero-sum thinking. These aren't problems aliens can solve for us. They're tests we have to pass ourselves, using the intelligence and creativity that evolution gave us, building on the cultural and technological tools our ancestors developed. If we do that, if we navigate the next few centuries without destroying ourselves, then maybe we'll be ready for whatever contact actually means. Ready to engage with other intelligences as peers rather than supplicants. Ready to contribute to whatever conversations happen between minds scattered across the galaxy. And if we don't, if we fail these tests, if human civilization collapses under the weight of its own contradictions, then 3 Atlas will continue its journey. And someday, millions of years from now, it might pass through another star system and transmit the same 3 pulses toward whatever species evolved there. 5 seconds, 8 seconds, 13 seconds. A mathematical greeting from builders who are dust, traveling through a galaxy full of civilizations that rose and fell, carrying a message that transcends any individual species. We recognized the patterns. We understood that mathematics underlies reality. We achieved enough to send this probe across the stars. Whether we survived after that, you'll never know. But we were here. We noticed the same things you notice. For a moment, measured in geological time, we existed and wondered whether anyone else was wondering too. Now we're passing that question to you. Epilogue, 850 words. It's been 3 months since I started investigating the 3i Atlas event. 3 months of FOIA requests, amateur astronomer forums, archived scientific papers, conversations with researchers who spoke carefully about what they could and couldn't say. I have more questions now than when I started. Did 3i Atlas transmit an intentional signal? I don't know. Was the spacecraft blackout related to that transmission? I don't know. Does the 180-year anniversary of Fatima mean anything? I don't know. Are we being monitored by civilizations that mastered interstellar travel? I don't know. But here's what I do know. On October 13th, 2025, something happened that doesn't fit comfortable explanations. Not impossible to explain naturally. Nothing in physics forbids any of it. But requiring stacked coincidences that collectively resist easy dismissal. Institutions that should be transparent about the event have been opaque. Data that should be accessible remains restricted. Questions that should generate scientific debate have been met with brief dismissals that don't address the full scope of observations. That opacity might reflect legitimate scientific caution. It might reflect bureaucratic inertia. It might reflect active information management around a potentially sensitive discovery. I can't distinguish between those possibilities from outside institutional walls. What I can say is this: whether 3i Atlas was natural or artificial, the event exposed how unprepared we are, culturally, institutionally, scientifically, to handle ambiguous potential contact. We need better frameworks for investigating anomalous observations without either premature sensationalism or excessive restriction. We need protocols for releasing ambiguous data that acknowledge uncertainty rather than forcing premature conclusions. We need cultural comfort with not knowing as the honest response to insufficient evidence. Most of all, we need to keep watching the skies. Because if October 13th, 2025 was contact or near contact, or the first in a series of increasingly clear signals, then more events will follow. More interstellar objects will arrive, more patterns will emerge, more opportunities to distinguish genuine communication from elaborate coincidence. And if it wasn't contact, if every element of this investigation resolves into natural phenomena and statistical noise, then we'll have learned something valuable about how pattern recognition can mislead, how coincidence can seem meaningful, how desperately we want to find signs of other minds in a universe that might leave us alone. Either way, the investigation continues. 3. Atlas is gone now, faded beyond detection, traveling toward Lyra at 32 kilometers per second. In 10,000 years, it will have covered barely 1/5 of a light year, still within what astronomers consider the Sun's gravitational neighborhood, despite having left the solar system proper. In a million years, assuming nothing intercepts it, it might pass within a few light years of another star. If that star has planets, if those planets evolved life, if that life developed intelligence and built telescopes, maybe they'll detect a small, dark object passing through their system at high velocity. Maybe their instruments will catch 3 pulses of ultraviolet light in a Fibonacci sequence. Maybe they'll investigate, debate, argue about whether the signal was natural or artificial. Maybe they'll write their own documentaries about what they found and what it might mean. And maybe across that million-year journey, 3i Atlas will have served its purpose, not to prove anything definitively, but to ask the question, to invite whoever notices to wonder whether they're alone, to demonstrate that other minds might be out there, contemplating the same patterns, asking the same questions, struggling with the same uncertainties. That might be all contact ever means in a universe where distances require geological timescales to cross, not conversation, not partnership, just occasional recognition, brief moments when intelligences separated by time and space and evolution notice each other across the void and acknowledge, we see you. We recognize the patterns too. We're here, or we were here, or we will be here. The universe contains minds. You're not alone in noticing its mathematical beauty. If that's what October 13th, 2025 represented, then the appropriate response is simple. Keep watching, keep wondering, keep building the civilizations and technologies that might someday send our own probes to other stars, carrying the same message forward. And maybe, centuries from now, when humanity has solved the problems that currently threaten to destroy us, when we've developed the long-term thinking and institutional stability required for interstellar projects, we'll launch our own network of probes, each one programmed to travel for millions of years, watching for signs of intelligence, ready to transmit 3 pulses when it detects anyone watching back. 5 seconds, 8 seconds, 13 seconds. A mathematical greeting from beings who noticed the universe speaks in patterns, who wondered whether anyone else was listening, who survived long enough to answer the question they once asked. Are we alone? Maybe not. Maybe the galaxy is full of species asking that same question, sending the same signals, maintaining the same patient vigil across time spans that reduce individual lifetimes to irrelevance. Maybe contact isn't an event. Maybe it's a process, slow, patient, measured in generations, requiring exactly the kind of long-term thinking that determines whether civilizations survive at all. Maybe 3. Atlas was just one more step in that process. And maybe, just maybe, we noticed.